Hi Lancers, it's Mrs. Allen again, and I'm going to go over these practice problems that you've been working on the last couple of days. So at the beginning, you just had to watch one of these videos, at least one of them, and explain how did you know that a chemical reaction occurred and how did it demonstrate the law of conservation of mass. And in each of these, you saw a change happen in the reactants that produced a new substance, and that's how you knew a chemical reaction occurred. So if you watch the first one, then you would have seen the two liquids combine together and get cloudy and make a precipitate, which is like a solid or a powder that was in that vial. And so that's how you could tell that a chemical reaction occurred. If you watch the second one, then you saw that balloon blow up and fill with gas. And that is your indicator that a chemical reaction occurred because it produced a gas. And then in the last one, you saw two things happen actually. You saw a color change where the two clear liquids turned to a bright yellow, and then it also got cloudy, which means a precipitate formed. And so that was your indicator that a chemical reaction had occurred. And then the second part was, how did that demonstrate the law of conservation of mass? Well, in each one of those, they showed you the beginning weight, the beginning mass of those reactants. And then after the reaction occurred, they showed you the ending mass, and it was the same. So from that, you saw that even though the substances totally changed, they became a gas, they changed color, they became cloudy and formed a solid, they did not lose any mass or gain any mass. And so that's the law of conservation of mass. They had the same mass before and after the equation. Okay, now we're going to go on to do these practice problems. So I'm going to close this box here. And to balance these equations, you just needed to count the number of atoms on each side of the equation and make sure that they balance. So let's start. The first one we have Ca, which is calcium. And on my left side of my equation, I only have one calcium atom right here. And then on my right side, I have one also. And then I have my oxygen on my reactant side. I just have one. And I'm just going to keep going down my reactant side. On my hydrogen, I also have one. And my chlorine, that's the Cl, I also have one. So I have one of everything on my reactants. Well, then it goes through this chemical reaction and recombines. And now, like I said, I had one calcium, but now I have two chlorines. I also have two hydrogens. You can tell by that subscript there, two hydrogens. And I have one oxygen. So I can see that this is not balanced. These do not equal each other. And so we have to change something because we know it can't occur this way because of the law of conservation of mass. So I know that I need two hydrogens over here and two chlorines because I only have one of each. So if I put a coefficient here of 2, that 2 applies to everything behind it. So that 2 applies to my hydrogen. So that 1 now becomes a 2. And that 2 applies to my chlorine. So that 1 also becomes a 2. And now you can see that each atom balances. So I have one calcium on each side, one oxygen atom on each side, two hydrogen atoms on each side, and two chlorine atoms on each side. So that is now a balanced equation. So let's go on to the next one. So now I'm on xenon and fluorine. So I have one xenon on this side, and I have one on this side. I have two fluorines on the left, and I have 6 on the right. Okay, so it looks like my xenons are balanced, but my fluorine is not. So in order to get this left side to be equal to 6, what can I multiply by? Well, I can multiply by 3. So 3 times 2 is 6. Cross that out. And my equation is balanced. Okay, so let's go to the next one. And we're going to do the same thing. So we have aluminum, and I have one aluminum on my left, and I have two aluminums on my right. I have 2 irons on my left, and I have only 1 on my right, so that's not balanced. I have 3 oxygens on my left, and I have 3 oxygens on my right. So my oxygens are balanced, but my iron and my aluminum are not. So what do I need to do here? Let's see. If I add a 2 over here, that will fix my aluminums, and they're balanced. And then if I add a 2 over here, that makes me have 2 irons. So I'm going to cross that out and add that, change that to a 2. And I have everything 2, 2, 3. Looks good. So that equation is now balanced. Now I'm going to move it up even more. Okay, so now I'm on this equation with copper and oxygen. And we're going to do the same thing. So I have 1 copper on my left. That's the Cu. And I have 1 on my right. So that looks fine. I have oxygen. I have 1 on my left. But I have 2 over here in my products. Gives me carbon. Capital C is carbon. I have 1 in my reactants. And I have 1 in my products. So it looks like the only thing that is unbalanced at this point is my oxygen. And I have 2 over here, which means I need to get 2 over here. So if I put this coefficient 2 in front of this molecule, then that will change this one. My oxygen will change to 2, but then I've also affected my copper. So now I have 2 coppers. So cross that out, that changes to 2. And so now my copper is unbalanced. And so that means since I only have 1 over here, if I put a coefficient of 2 over in front of this one, 2 Cus, that's 2 coppers. I'll change that to a 2. And we are balanced. Okay. Moving on. So now I have magnesium and oxygen in this one, in this equation. And I have 1 magnesium on my left side and 1 on my right side. And then I have 2 oxygen atoms on my reactant side and only 1 over here. Okay, so I'm going to have to do some balancing again. So I'm going to do the same, kind of the same as last time. I'm going to put a coefficient of 2 on this product, which will apply to my oxygens that I'm trying to balance, but it will also, it's like the distributive property, right? So it'll apply to my oxygens, but it'll also apply to my magnesiums. So 2 oxygens, that balances my oxygens, but again, my magnesiums also are affected. So I'm going to put a 2 here, which means I'm going to have to go back to this side and add a coefficient in front of the magnesium on that side. Cross that out. That becomes a 2. And it is now balanced again. I'm going to erase this little part right here so that E doesn't look like anything. And we see that this equation is balanced. Okay, now I'm going to go to this one. Looks really long. It's got a lot of different elements in it, but that's okay because it just is the same process. So K is potassium. Looks like I have 2 potassiums. C is carbon, and it looks like I just have 1 carbon. H is hydrogen, and I've got right here 2 hydrogens. S is sulfur, and I just have 1. And O is oxygen. Okay, so I have 3 right here, and I have 4 right here. So that would give me a total of 7 oxygens on my reactant side. Now I'm going to look at my product side and do the same thing, count them up. So potassium, that's the K, I have 2. Carbon is right here, I just have 1. Hydrogen, I have 2 right here. Sulfur, I have 1. And oxygen. Now my oxygen is all split up. So I have 4 here plus 2 here. That's 6 plus 1 more is 7. Okay, so let's look and see what I need to do. Potassiums are balanced, carbons are balanced, hydrogens are balanced, sulfurs are balanced, oxygens are balanced. So this one is already balanced. You don't have to add anything to it. And so sometimes you'll find equations do not need to be balanced. They're already written as balanced, and that was the case here. Okay, let's move on to this one, number 7. So we have Pb is lead, and I have 1 lead atom. O is oxygen. I have 1 here and I have 3 here, so that gives me 4. Hydrogen, I have 1 on my reactant side, and nitrogen, I have 1. And let's look over here. So Pb, I have 1. Now this we haven't really talked about, but if you use the same ideas that you do in math, then you might know that you should multiply everything inside of the parentheses. So this 2 means that there are 2 molecules of this NO3. So it's going to be a little trickier to count it up. So 2 times my nitrogen means I have 2 nitrogens. And I have 3 atoms of oxygen times 2. That means 6. But don't forget I have 1 over here, and that's 7. So I have a 7 here. And then what am I missing? Oh, my hydrogens. And I have 2 hydrogens here, the H2. So let's see what is balanced. We have a lot that's not balanced here. So I'm going to go ahead and start with these 2. So I see that I have 2 hydrogens and 2 nitrogens on this side. I only have 1 of each over here. So I'm going to put a 2 in front of this molecule, HNO3. And remember, this 2 applies to everything in this molecule. So it's going to change a lot of things. So it's going to change my hydrogen. It's now going to be 2. My nitrogen is now going to be 2. That's what we wanted. Then it also applies to this oxygen molecule here. So I have 3, or this oxygen atom, and I have 3 oxygen atoms. So 3 times 2 is 6. But don't forget I had this 1 over here. And so that changes this to 7. Now let's check and see where I am. Leads are balanced. Oxygens are now balanced with 7 on each side. Hydrogens are balanced with 2, and nitrogens are balanced with 2. So this one is good. We're going to the last problem. Okay, Na, sodium. I have 1 sodium on my reactant side, and I have 2 on my product side. You can see that because it's got the subscript by the Na. Hydrogen, I have 2 on my reactant side, and I have 2 on my product side. S, sulfur, I have only 1 because that S does not have any subscripts on it, and it doesn't have parentheses. So I just have 1 sulfur, and I also just have 1 sulfur over here. And then oxygen, I have 4 oxygens on this side. Oh gosh, 4. And over here, I have 4. So let's see what I need to do. So it looks like the only thing that's not balanced is my sodium. And so that is an easy fix. Since I have 2 on this side and I only have 1 over here, all I have to do is add my coefficient of 2. That's going to change this one to 2 as well. And then I can see that everything else is balanced and it checks out. Okay, I hope after doing all these problems that you feel pretty comfortable in being able to balance equations. If you don't, please reach out to your teachers and we can help you with that. We can also provide you with some extra practice problems if you'd like that. So please reach out and let us know how you're doing. Thanks.